Assalamu alaikum students. Let's go for the next few questions of October, November 19, paper 4-1, the mechanics paper. And this is question number 4, the next auditorium, in which he is asking you two blocks A and B of masses 4 and 5 kg respectively are joined with light insensible spring where tan alpha is equal to 7 by 24. The spring is parallel to the line of greatest slope of the plane B above A. B is above A. A force of magnitude 36 Newton as shown over there, X on B, parallel to the line of greatest slope of the plane. Find the acceleration of the blocks and the tension in the string. Okay, let's go for this now. That if we see that first of all, this is tan alpha. So from there we can find the value of alpha. So alpha is equals to tan inverse of 7 over 24. And this gives us a value of 16.26 with the calculator. Now let's resolve this. This is 4 kg. So when you go down, this is obviously 40 Newton. And when you resolve these two, here is the same alpha. So this is 40 sine alpha, which is going this way. 40 sine 16.26. Now, the next one is here, which is for the 50. So if you resolve it down, the weight is there, which is 50. And obviously the same here, this is the same angle alpha. So it's going to be 50 sine alpha. Now this force is on this direction. And there is this force as well. So if we see only single force, 36 Newton, is pulling both of the objects forward. So F minus R is equals to MA. Now F minus R, 36 minus both of these, 40 sine 16.26 and 50 sine 16.26 is equals to MA. Now both of these are being pulled up. So 9A. So let's simplify this with the calculator. When you simplify this, this gives us 10.8. And dividing by 9, we get acceleration here, 10.8 divided by 9, which gives us 1.2 meter per second square. Now the second thing, he asks us the tension in the string. So this is the string which is pulling only this one. So the tension is obviously going this way. So for the second equation, tension minus 40 sine 16.26 is equals to 4A. And A is the same. So T is equals to 4 times by 1.2 plus 40 sine 16.26. And if you simplify this, this gives us 16 Newton. This is for question number 4, part 1. Now let's go further to the next one. What does it say? Okay. It says at a particular instant, the speed of the block is 1 meter per second. Find the time after this instant as it takes for the blocks to travel 0.65 meter. So S is equals to UT plus half AT square will help us to do this. This is 0.65, 1 times by T, half. Acceleration is 1.2 and T square. This will give us a quadratic equation. Upon solving that, we will be able to get the value of time T, 0.6 T square plus T minus 0.65. And upon solving this, we get the value of T is equals to, by using mod 0.53. The value of t is 0.5 seconds. Now let's go for question number 5. Question 5 says, that, okay, here. So some of the forces are seen over there, and it says that given that these forces are in equilibrium. Okay, fine. In equilibrium, it means that we will be looking for here now. Let's resolve this first. This is f sine theta. And on this side, if you see f cos theta. Similarly, this is having 4.5 sine theta here, which is sine 20 degree. And this is going upward. On this side, the horizontal one, 4.5 cos 20 is there. Similarly, if you resolve this one, this is going downwards, 7.5 sine 60, and this side 7.5 cos 60. So we can make two equations over here. One is with the horizontal forces, one is with the vertical forces, and the vertical forces say f sine theta is equals to f sine theta is equals to 7.5 sine 60. This is the only one which is going down. This one was going up, so minus this 4.5 sine 20. And if we simplify this, we get it equals to f sine theta is equals to 4.96. 4.96. This is our equation number 1. Similarly, resolve the cos ones. F cos theta is equals to 4.5 cos 20 plus 7.5 cos 60. And simplifying this, we get it 7.98 f cos theta. This is our equation number 2. Now, solve this simultaneously by dividing 2 by 1. Divide 2 by 1. F sine theta, sorry, 1 by 2, sorry. 1 divided by 2. So it's f sine theta over f cos theta is going to be tan theta is equals to 4.96 over 7.98, and tan inverse of this gives us 31.86. Now by placing the value of 31.86 anywhere over here, we can get the value 4.96 divided by sine 31.86, and this gives us a value of 9.4 Newton. Now let's go further. And what does it say? Okay, it is given that the values of f and theta are 9.5 and 30. So find the acceleration of the ring, and the acceleration of the ring is 1.5. Find the mass of the ring. Now, since it is going right side, so f is 9. F cos theta. F cos theta means 9.5 cos 30 minus the two values of the cos, which are 4.5 cos 20 minus 7.5 cos 60. This will give you the resultant cos. And upon simplification, we are able to get the value as 0.247. This is the net force which is applied. So applying the Newton's second law, F equals to ma, we will be able to get the mass. Mass equals to force over the acceleration. Force is 0.247 and acceleration was 1.2. So if you divide it, we get it equals to, sorry, this is acceleration is here 1.5. So dividing it, we get it 0.166 kg. So this is all for this tutorial. Only the question number 4 and the question 5 is done here. So we'll see the next tutorial, inshallah, in a while for question number 6 and question number 7. I hope this will be helpful to you for these two questions, and you will get an idea that how to deal with the questions. God bless you. Take care. Good luck.